Okay, good afternoon, students. So this is the second live interaction session of the course Network Security. Uh, there were no questions asked in the asked using the link that we shared. So now, if you have any live questions, you can ask them, please. Uh, so while we wait for the live questions, I'll go through a simple example. So this example is in the context of PGP, which we discussed for secure email. So we discussed in the video lectures how Alice can securely send an email to Bob using PGP. And this block diagram illustrates the procedure. So P is the message that is to be sent securely. So we first find its digital signature by finding its hash and then signing it with the sender Alice's private RSA key to get the signed hash. And then we yeah, actually the screen needs to be shared. Just one. Okay, fine. So in this example, we are discussing, recall that in the video lectures, we discussed how Alice can securely send an email to Bob using PGP. So this block diagram shows the procedure, this block diagram was discussed in the slides. So P is the message which is to be sent, then its digital signature is found. So first the message is hashed and then uh, it is signed with the private key of the sender Alice. Uh, and then the plaintext message is concatenated with the signed hash to get this P1, which is then compressed using the zip program. And then we encrypt it using the block cipher idea and the secret key KM, which is generated randomly. And then this secret key KM needs to be shared with the receiver Bob. So it is encrypted using the receiver Bob's public key. And then the concatenation of P1.z along with the key KM encrypted with the public key of Bob that is converted into base 64 format and sent over the network. So this is the basic PGP. Now let's discuss a variant of that. Now, instead of the basic PGP, suppose Alice wants to securely send an email simultaneously to n recipients. Let's call them P1 to Pn. So how can we modify the PGP program to enable simultaneous transmission to n different receivers? Uh, so obviously we require the modified scheme to be as efficient as possible, and it should still provide the properties that the basic PGP provides, namely confidentiality, message integrity, compression, and key management. So how do we generalize the basic PGP scheme to enable simultaneous transmission to end receivers? So one simple brute force way is just to repeat this block diagram n times. So Alice just independently sends the email message to B1 to BN. So she just separately sends the message to B1 to BN. So that's a brute force way, but it is inefficient because all these operations need to be repeated n times. So we observe that all these operations are most of these operations are common to all the receivers B1 to BN. The only thing that is specific to the receiver is this operation here, where the receiver's public RSA key is used to encrypt the symmetric key KM that is used for encrypting the plaintext message. So we can just repeat this part, which is specific to the receiver Bob, and the rest can be common. It can be the other operations can be done only once. So here is the procedure. So let the email plaintext message that needs to be sent to the n receivers be P. So again, P1.z is found and encrypted with IDI and KM as before. So P1.z is generated in exactly the same manner as in the basic PGP. And again, we generate a random key KM and then encrypt P1.z using IDEA and the randomly generated key KM. So now this KM needs to be shared with the receivers, B1 to BN. So earlier, what we were doing is we were just encrypting KM with Bob's public key. But now instead of Bob, there are n receivers, B1 to BN. So we just separately encrypt KM with each of the public keys of B1 to BN. So KM is separately encrypted using RSA and the public key, let's call it EBI of BI for each I equals 1 to n. So then P1.z encrypted with IDEA and KM, uh, and the n encrypted versions of KM are concatenated, and then they are converted to base 64 format and sent on the network. So the only thing that changes in this block diagram is that now this KM is uh, separately encrypted using the public keys of B1 to BN, and then these n different encryptions are concatenated to the encrypted plain text message, and then the result is converted into base 64 format and sent over the network. So each recipient BI can decrypt the key KM using the private key corresponding to EBI. So that's the decryption part. So each of these n receivers is able to decrypt the message P using their own private key. Yeah, so this concludes the example that I wanted to discuss. Now, you can ask any questions if you have any questions. So any questions about the video lectures or this example that we just discussed? Okay, so if there are no questions, then we'll close this session here. Thank you.